3. I/ATLAS has captured the attention of the world once again. Fresh images released just days ago by NASA and affiliated observatories reveal details so strange that even seasoned astronomers are struggling to explain them. Across social media and scientific forums, speculation has exploded. What was once a distant, enigmatic interstellar visitor is now at the center of a whirlwind of scrutiny, debate, and public fascination. The story of 3 I/ATLAS begins with its initial discovery, an object that did not originate in our solar system. Unlike comets or asteroids familiar to scientists, it followed a trajectory that suggested an interstellar origin. The object's motion and speed were inconsistent with objects gravitationally bound to the sun, raising immediate questions about its composition, structure, and purpose. Meanwhile, C/2014 UN271, an enormous object lurking on the fringes of the solar system, has been steadily making its way inward. Its sheer size is staggering, dwarfing most known comets and some small planets. Both objects together are redefining what we understand about celestial bodies entering our neighborhood, and the combination of their mysteries is fueling widespread intrigue. The first official images of 3 I/ATLAS revealed more than just a glowing comet-like body. High-resolution captures hinted at unusual surface patterns and reflective patches that seemed inconsistent with typical cometary ice and dust. These features sparked immediate debate about whether the object could be a natural formation, or perhaps something far more exotic. Leading astronomers and astrophysicists weighed in cautiously. Some suggested the anomalies might be caused by uneven surface ice sublimation, while others proposed that the reflections hinted at structures possibly of artificial origin. Statements from observatories emphasized that speculation should be tempered by rigorous analysis, yet the unusual characteristics were impossible to ignore. C/2014 UN271 is no less astonishing. Estimates suggest it measures over 100 kilometers in diameter, a size rarely observed for comets. Its reflectivity is higher than expected, implying unusual surface material or composition. The sheer scale of this object has astronomers recalibrating models for large, distant bodies within the solar system. Updated trajectory analyses for both objects have been released, showing paths that are precise yet unpredictably influenced by minor gravitational interactions. For 3 I/ATLAS, projections remain largely outside Earth's orbital path, though any interstellar object carries inherent uncertainty. C/2014 UN271, on the other hand, follows a trajectory that will bring it closer to the Sun than initially anticipated, triggering closer monitoring. The new images reveal mysterious features on 3 I/ATLAS. Protrusions, subtle angular formations, and reflective areas suggest complexities far beyond a standard comet nucleus. These findings have divided the scientific community between natural explanations and more speculative hypotheses regarding structure and origin. Contextualizing 3 I/ATLAS within interstellar history adds further intrigue. Unlike Oumuamua, which was cigar-shaped and largely enigmatic, and Borisov, which displayed typical cometary characteristics, 3 I/ATLAS combines high velocity with structural anomalies. It appears to occupy a category of its own, prompting astronomers to reconsider the diversity of interstellar objects. Public interest has exploded in response. Social media platforms are flooded with images, videos, and theories. Some have suggested everything from alien probes to energy-harvesting megastructures. While largely speculative, the interest reflects the public's fascination with unknown celestial phenomena. NASA responded with measured statements, emphasizing careful observation and avoiding unnecessary alarm. Officials stress that while the objects are unusual, current data does not indicate imminent danger. The focus remains scientific observation, data analysis, and maintaining public understanding based on evidence. High-resolution imaging from the Hubble Space Telescope and the James Webb Space Telescope has provided unprecedented clarity. Fine surface details, patterns, and reflectivity gradients are now visible, offering insights previously impossible to obtain. These images have both answered some questions and generated dozens of new ones. Radio telescopes have been deployed to scan the objects, revealing rotational properties and possible surface texture. Analogous to sonar, these scans allow scientists to model the shape and rotation of 3 I/ATLAS, which appears more irregular and complex than any comet previously documented. Composition analysis has yielded unusual chemical signatures. Observations suggest elements and compounds inconsistent with typical cometary bodies, including trace materials rarely found in the outer solar system. While natural explanations remain plausible, the data continues to confound researchers. Rotation patterns of 3I/ATLAS have been peculiar. Some areas of the nucleus appear to rotate faster than others, hinting at an uneven internal structure. This irregular spin contributes to the object's unpredictable light reflections and anomalous motion. Brightness fluctuations have been observed, with sudden flares detected over short time spans. Scientists are debating whether these are caused by gas emissions, solar interactions, or an as-yet unknown internal process. The data remain inconclusive but highly suggestive of complex activity. Meanwhile, C/2014 UN271 has exhibited comet-like behavior at distances much greater than previously thought possible. Outgassing has been observed, producing tails and jets despite the weak sunlight far from the sun. This challenges current models of cometary activity and thermal processes. The gravitational influence of these objects is also under study. While no immediate threat to planets has been identified, minor perturbations in the outer solar system are measurable. Their interactions with Kuiper belt objects and other distant bodies provide valuable data for orbital mechanics and celestial dynamics. Public speculation has intensified alongside scientific updates. Online forums are rife with theories ranging from natural anomalies to apocalyptic predictions. While much of this is sensational, it underscores the human fascination with the unknown and our desire to explain it in narrative form. Historical records of bright comets and celestial phenomena have been revisited. Some researchers are investigating whether previous sightings of anomalous sky objects could have parallels to 3I/ATLAS and C/2014 UN271, potentially offering insights into long-term patterns of interstellar visitors. A particularly controversial hypothesis involves the dark object theory, suggesting that 3I/ATLAS might conceal a hidden metallic or artificially structured core. While heavily debated, proponents point to unusual reflections and rotational anomalies as supporting evidence, though mainstream scientists remain skeptical. The unexpected acceleration and deceleration of 3I/ATLAS have added to its mystery. Unlike natural comets, which follow predictable trajectories based on mass and gravity, minor deviations suggest forces acting upon it that are not fully understood, prompting ongoing observation campaigns. Some scientists have speculated about potential energy sources powering these anomalies. Natural processes, including outgassing and rotational energy, are likely explanations, but alternative hypotheses propose unknown propulsion mechanisms or interactions with cosmic energy fields. Simulations tracing 3I/ATLAS interstellar trajectory suggest origins in nearby star systems, though definitive identification remains impossible. The object may have traveled millions of years across the galaxy, offering a rare glimpse into materials and conditions far beyond our solar system. Dark matter interactions have also been proposed. Could 3I/ATLAS be influenced by unseen forces? While speculative, models exploring gravitational anomalies provide intriguing possibilities, connecting these objects to broader cosmic phenomena. Amateur astronomers have played a significant role capturing images and data from backyard telescopes that complement professional observations. This global collaboration underscores the democratization of astronomical research in the digital age. Media coverage has escalated, often prioritizing sensational headlines over cautious analysis. Efforts by scientists to separate fact from fiction are ongoing, but the viral nature of images and videos ensures continuous public attention. International cooperation has intensified. NASA, ESA, CNSA, and JAXA have coordinated observation campaigns, sharing data and models to track the object's behavior with unprecedented precision. This collaboration is shaping new standards for rapid, global astronomical monitoring. Risk assessments have been conducted, with the overwhelming consensus indicating that both objects pose no immediate danger to Earth. Nonetheless, their presence is a reminder of the importance of vigilance and preparedness in monitoring celestial bodies. Advanced imaging has revealed structures previously unseen. 3D reconstructions from multiple perspectives suggest surface geometries that defy simple cometary explanations, fueling debates about their origin and composition. Spin-off discoveries include smaller companion objects accompanying C/2014 UN271, suggesting complex formation or fragmentation processes. These secondary bodies provide valuable data on gravitational and compositional interactions. Radio scans have been deployed to detect potential signals. While no confirmed artificial transmissions have been found, subtle anomalies in emissions continue to intrigue researchers and encourage cautious monitoring. Public interest, fueled by social media, conspiracy theories, and speculative reporting, continues to grow. Viral content often distorts data, making public education and scientific communication more critical than ever. Scientists stress careful interpretation. While anomalies are compelling, evidence-based reasoning remains the cornerstone of credible understanding. Each discovery, however strange, fits into an evolving framework of astronomical knowledge. Behavior under solar radiation has been particularly surprising. Both objects respond in ways inconsistent with standard models, suggesting complex surface or internal chemistry. These interactions reveal nuances about material properties under extreme conditions. Predictive modeling using AI and supercomputers has projected future trajectories and potential behaviors. While predictions remain probabilistic, simulations provide essential tools for understanding these dynamic objects over time. Peer-reviewed studies are beginning to emerge, offering rigorous analysis of observed anomalies. Observational data, statistical models, and chemical signatures form the basis for a growing body of scientific literature that will shape future understanding. Cross-disciplinary interest is expanding. Physicists, chemists, and engineers are analyzing data for insights into composition, energy processes, and structural anomalies, leading to innovative research that bridges multiple fields. Speculative astrobiology raises tantalizing possibilities. Organic compounds detected could hint at prebiotic matter or even seeds of life, linking these interstellar visitors to broader theories of panspermia and the distribution of life in the cosmos. Extreme scenario planning has been undertaken. NASA and global agencies evaluate highly unlikely catastrophic outcomes, using these models to prepare response strategies while stressing the low probability of such events. Updated public images show three I/ATLAS in unprecedented clarity. The intricate shapes, reflective surfaces, and surface irregularities suggest a level of complexity that surpasses initial expectations and continues to challenge conventional understanding. Interactions with solar wind, radiation pressure, and magnetic fields reveal behaviors that are both typical and anomalous. Monitoring these effects contributes to knowledge about space weather and its influence on unusual celestial objects. AI-assisted analysis has identified subtle patterns invisible to human observation, uncovering potential structural symmetries, rotation anomalies, and minute emissions that may indicate previously unrecognized activity or composition differences. Near-Earth observation strategies have been reinforced. Global telescope networks, both professional and amateur, ensure continuous monitoring to detect any changes, providing early warning and data for scientific study. Philosophical and societal implications abound. Humanity's fascination with the unknown is amplified by these objects, prompting reflections on our place in the universe and the mysteries that lie beyond our solar system. Concluding scientific perspectives emphasize caution, curiosity, and methodical study. While anomalies inspire speculation, they are driving advances in astronomy, material science, and interstellar research, expanding the boundaries of knowledge. Future discoveries are anticipated with anticipation and suspense. Upcoming observations from next-generation telescopes promise to clarify many mysteries while potentially revealing surprises that could reshape our understanding of the cosmos. Public advisories encourage careful consumption of information. Scientists urge that facts and data guide understanding, emphasizing the value of education, critical thinking, and scientific literacy in the face of sensationalism. Finally, reflection on the vastness of the universe and the incredible nature of discovery offers perspective. These interstellar visitors, mysterious and captivating, remind us of the awe-inspiring scope of space and the enduring curiosity that drives humanity to explore the unknown. As telescopes continue to focus on 3I/ATLAS, minute surface features are becoming increasingly visible. Patterns emerge in the reflective patches, sharp edges, angular ridges, and symmetrical formations that defy easy explanation. Scientists debate whether these are natural fractures in ice and rock or evidence of some form of artificial design. The images have reignited discussions about how interstellar objects might differ fundamentally from solar system bodies. C/2014 UN271, meanwhile, has begun to show evidence of increased outgassing as it approaches the Sun. Jets of gas and dust erupt from its surface in unexpected locations, creating a spectacular display that is being documented by observatories worldwide. The behavior challenges long-held theories about how solar radiation interacts with distant cometary material. Researchers are particularly intrigued by the interplay between 3I/ATLAS's rotation and its irregular shape. Some areas appear to reflect light more strongly due to subtle shifts in the object's spin. This variation complicates measurements and has led to new modeling techniques to predict light curves and rotational dynamics. The possibility of an artificial structure within 3I/ATLAS remains speculative but compelling. Some astronomers point to the object's anomalous acceleration as potential evidence of internal propulsion or energy sources. While mainstream science urges caution, the mere consideration of this possibility is unprecedented in the study of interstellar objects. In contrast, C/2014 UN271 seems entirely natural, yet its scale continues to defy expectations. With a diameter exceeding 100 kilometers, it is the largest object of its kind ever observed at such distances. Comparisons with smaller, more typical comets highlight the enormous variability of bodies within our solar system. Observatories are now coordinating to produce three-dimensional reconstructions of both objects. By combining multiple images from different angles and wavelengths, scientists hope to understand surface composition, internal structure, and potential anomalies in greater detail. This collaborative effort represents one of the most comprehensive observation campaigns in recent decades. Amateur astronomers have played a surprisingly critical role in these discoveries. Backyard telescopes equipped with high-quality cameras have captured additional data points, filling in gaps between professional observations. In some cases, these contributions have led to early detection of transient phenomena, such as sudden flares or temporary bright spots. Public fascination continues to grow. Social media trends range from scientific breakdowns to speculation about extraterrestrial technology. Conspiracy theories, while largely unfounded, have taken root, showing the human tendency to seek narratives in the unknown. Educators and scientists are working to provide accurate context while maintaining public engagement. NASA has emphasized that both objects are under constant monitoring. Their orbital paths, chemical signatures, and behavior under solar influence are being tracked meticulously. While 3I/ATLAS remains on a hyperbolic trajectory that will take it out of the solar system, C/2014 UN271 will pass relatively close to the Sun, providing a rare opportunity for in-depth study. New data suggests that 3I/ATLAS may be releasing material in unexpected ways. Observations of sudden brightening events imply that the object is not merely passive, but actively interacting with its environment. These emissions could result from sublimating ices, dust ejection, or more exotic processes. The shape of C/2014 UN271 has also surprised researchers. Early models assumed a roughly spherical or ellipsoidal nucleus, but images reveal elongated ridges, protrusions, and irregular depressions. Such formations suggest a complex history of accretion, collisions, and internal stresses over billions of years. Some scientists are investigating the possibility that 3I/ATLAS carries organic or prebiotic compounds. Spectroscopic analysis has identified faint signatures consistent with carbon-based molecules, raising questions about the potential for panspermia or the delivery of organic material from other star systems. Both objects are interacting with the solar wind in ways that provide new insights into heliophysics. Charged particles streaming from the Sun are influencing surface and tail activity, creating dynamic patterns that can be observed in real time. These interactions offer a laboratory for studying space weather effects on unusual celestial bodies. AI-assisted analysis has revealed patterns and anomalies invisible to the human eye. Machine learning algorithms have identified subtle brightness fluctuations and potential structural symmetries that hint at complex internal processes. These findings continue to refine our understanding of interstellar and solar system objects. C/2014 UN271's approach has prompted discussions about potential missions. While a direct probe may be decades away, orbiters or flybys could provide unparalleled data on large cometary bodies. Such missions could illuminate not only the nature of C/2014 UN271, but also broader questions about solar system formation. Historical comparisons are being drawn with past celestial phenomena. Bright comets, supernova-like flares, and anomalous asteroid behavior are being re-examined through the lens of 3I/ATLAS and C/2014 UN271. These analyses may reveal overlooked patterns in astronomical history, offering insights into the frequency of interstellar visitors. The public reaction has been both fascinated and fearful. Viral content, animated simulations, and speculative commentary dominate digital spaces. Scientists are responding with calm, evidence-based explanations, emphasizing the importance of data over conjecture while acknowledging the excitement generated by these objects. Radar imaging has added another layer of detail. By bouncing radio waves off the objects, astronomers can infer surface texture and roughness. For 3I/ATLAS, these scans suggest a highly irregular surface with varied reflective properties, consistent with observations from visible light telescopes. C/2014 UN271 has displayed faint satellite-like companions. These smaller fragments orbit the main body, hinting at past fragmentation or complex formation processes. Observing their motion provides additional information on the object's mass, gravitational influence, and internal cohesion. SETI initiatives have scanned both objects for potential artificial emissions. No confirmed signals have been detected, but faint anomalies in the data remain under study. While the likelihood of intelligent origin is extremely low, the process highlights the rigor of modern astronomical investigation. Media coverage has amplified speculation. Headlines predicting alien contact or catastrophic impacts proliferate, even as scientific agencies issue careful clarifications. This dichotomy underscores the challenge of communicating complex phenomena to a global audience. Scientists continue to stress that anomalies do not equate to threats. Instead, they offer opportunities to expand knowledge, test theories, and refine observational methods. Both 3I/ATLAS and C/2014 UN271 are laboratories for understanding physics, chemistry, and celestial mechanics under extraordinary conditions. Observations under varying solar angles reveal additional surprises. Both objects react to sunlight in ways that challenge expectations, with some regions exhibiting delayed or enhanced activity. This behavior provides clues about surface composition, thermal conductivity, and structural heterogeneity. Supercomputers are running simulations to predict future behavior. For 3I/ATLAS, this involves extrapolating hyperbolic trajectories and potential interactions with interstellar medium. For C/2014 UN271, models focus on solar heating, outgassing patterns, and tail development as it approaches perihelion. Peer-reviewed studies are beginning to appear, each adding pieces to the puzzle. Spectral analysis, orbital mechanics, and compositional data are meticulously documented, reinforcing the scientific community's commitment to transparency and rigor. Cross-disciplinary collaboration is flourishing. Physicists, chemists, and planetary scientists are pooling expertise to understand anomalies, test hypotheses, and develop predictive models. These collaborations highlight the importance of integrating multiple perspectives in addressing complex astronomical questions. Astrobiological implications remain tantalizing. The presence of organic molecules, combined with interstellar origin, raises questions about the distribution of life-forming compounds across the galaxy. While speculative, this research informs broader debates about life in the cosmos. Emergency preparedness exercises, though largely precautionary, have been conducted to model extremely unlikely impact scenarios. These exercises are part of a broader strategy to ensure readiness while emphasizing the very low probability of catastrophic events. Latest images of 3I/ATLAS show features of unprecedented clarity. Surface ridges, angular formations, and reflective regions suggest complexities that continue to challenge natural explanations. These observations fuel both scientific curiosity and public imagination. Interaction with solar wind, radiation, and magnetic fields continues to provide insights. Anomalous flares and sudden brightness changes offer data on the object's physical responses, contributing to a more nuanced understanding of space weather effects. Machine learning continues to refine our knowledge. Algorithms have detected subtle periodicities and symmetries in both brightness and motion, suggesting internal processes or structural peculiarities not immediately visible through direct observation. Near-Earth observation networks are fully engaged. Coordinated telescopes, both professional and amateur, provide continuous monitoring to ensure that any sudden changes in trajectory or activity are captured and analyzed promptly. These celestial phenomena have inspired philosophical reflection. The presence of such extraordinary objects invites contemplation of humanity's place in the universe, the limits of knowledge, and the mysteries that still await discovery beyond our solar system. Scientists conclude with caution tempered by excitement. Each anomaly, every unusual flare or reflection, represents an opportunity to expand the boundaries of astronomy and interstellar science. Observation continues, promising new insights and discoveries. Future studies will provide even more clarity. Planned observations from space-based and ground-based telescopes are expected to resolve lingering questions, offering higher resolution images and more precise compositional data. The anticipation is palpable. Public advisories continue to emphasize rational understanding. Sensationalism is countered with education, ensuring that excitement about these objects does not escalate into unwarranted fear. Knowledge and curiosity remain the guiding principles. Finally, as humanity watches these interstellar travelers, there is awe and wonder. 3. I/ATLAS and C/2014 UN271 remind us of the vastness of space, the complexity of celestial phenomena, and the enduring drive to explore the unknown. Our universe remains as mysterious as it is magnificent, and these objects are yet another testament to its infinite possibilities.